You are listening to the Vocal Technologist. Spoken tech for your ears.
If you've been watching the security landscape lately, it feels less like you're dodging raindrops and more like you're in the middle of a continuous targeted storm.
That's a good way to put it. It's just a constant barrage of alerts.
Right. Massive data dumps, 0 days, really sophisticated ransomware. But the big shift we're tracking isn't just that there are more attacks, it's that the digital dangers are now, showing up as immediate, high-stakes physical threats.
It's true. That whole idea of a perimeter, it's gone. We talk about network perimeters all the time, but the most important boundary that's been dissolved is the human trust boundary.
Exactly. So for this analysis, we're going to try to filter through all of that, distill the core insights, the stuff you really need to know that show how threat actors are adapting. We need to focus on where those trust boundaries are really breaking down. Okay, let's unpack this, starting with the most vulnerable spot of all, the human mind.
Yeah, the human boundary is being ruthlessly exploited by generative AI right now. The most alarming trend isn't your generic email phish anymore.
Yeah.
It's these interactive deepfakes in super targeted spear phishing campaigns. We're talking AI-generated voices, videos that perfectly mimic company execs.
And the effectiveness is, it's frankly terrifying. I saw the reported success rate.
It's reportedly fooling 99% of people. Just think about that for a second.
99%.
If a trusted executive's voice on what looks like a real video chat asks you to move a large sum of money or break protocol, the average well-meaning employee has almost zero chance of spotting that.
It makes all that old security training about check for typos seem quaint.
It's obsolete. We have to start training people for the fact that you can't trust your own eyes and ears anymore.
And then beyond just the deep fakes, the entire process of phishing has become this psychological masterpiece. We saw a breakdown of an Apple account attack that wasn't just a simple link.
Oh, that one was brilliant.
It was a full-on, multi-stage social engineering campaign.
And brilliant because it weaponized Apple's own systems against the user. It turned a security feature into a source of panic.
Exactly. So it starts with a flood of multi-factor authentication prompts hitting your device. Then you get SMS codes you didn't ask for.
So you're immediately on edge.
Right. Then an automated call comes in. It says your account is under attack and even gives you a case number.
But that's just the setup. The critical step is what happens next.
A human calls you. A professional-sounding employee calls right after the automated one, references the exact prompts, the exact case number.
Establishing instant trust.
And they offer to help you secure your account. They guide you step by step right to a very sophisticated credential harvesting site sent over SMS. It's just designed to make you ignore your own defenses out of panic.
And that weaponization of legitimate platforms is it's everywhere. Look at LinkedIn.
Your reply phishing tactic.
It's rampant. Scammers create fake company pages, something like Linked Very.
Right, and they just flood public posts with these fake violation warnings.
Exactly. And they use LinkedIn's own official URL shortener, lnkd.nn, to hide the malicious links.
So it looks totally official.
It looks internal. People just click. They're exploiting the very structure of the platform we trust.
Okay, so we've established how attackers are breaking the human boundary. But at the same time, the sheer volume of data being pulled out of corporate systems, it tells another story about scale and failure.
The scale is immense, and the targets are all over the place. Take the Spanish utility company Endesa.
That was a big one.
A major compromise of their commercial systems. Over 20 million customers' data exposed.
20 million. And we're not just talking emails here. This was
Identification details, national IDs, contract info, and crucially, IBAN payment data.
the actual bank account number.
They reported passwords were safe, but the potential for identity theft there is just massive.
And then you have these really high-stakes government leaks, like the one involving ICE and Border Patrol.
Yeah, a Department of Homeland Security whistleblower released the PII, personally identifiable information, of about 4,500 agents.
And that included what? Names? Work emails?
Roles, even detailed resume data. That's a leak with immediate real-world consequences. It puts the personnel and their families at physical risk.
It's not just a digital cleanup at that point.
Not at all. And then on the consumer side, you had all that chaos around Instagram.
The alleged leak of 17.5 million accounts.
Emails, usernames, some location data. Now, Instagram's position is that it wasn't a core breach.
Right. They said it was a flaw in an API that let people send mass password reset emails.
But look, whether it's a database breach or an API abuse, for the user, the outcome is the same. Your trust is just gone.
And speaking of eroding trust, threat actors are hitting core development environments more and more. Take the Target incident.
That was a serious one. An unknown actor claimed they stole a huge chunk of internal source code and documentation.
And the real kicker was that Target's own employees confirmed the samples were legit.
They had to take their Git server completely offline from the internet, instantly.
When source code leaks, that's the kind of security disaster that just keeps on giving for years.
Absolutely. And they're not alone. Nissan just got hit by the Everest ransomware group. They claim to have stolen 900 gigabytes of financial and operational documents. It just shows that for these big global companies, security isn't a project, it's a recurring existential fight.
Okay, we've covered the human element and the terrifying scale of data leaks. So now let's shift to some of the really, really sophisticated technical stuff we've seen lately. Here's where we get into what you could call architectural trust failure.
We have to talk about virtualization. For 2 decades, the hypervisor has been the ultimate trust boundary.
Yeah.
The thing that keeps virtual machines isolated.
The Great Wall.
The Great Wall. And that wall has now officially been breached.
You're talking about the Chinese-linked actors exploiting those VMware ESXi 0 days.
Exactly. 3 separate 0 days, CVE 2025, 222224, 25, 26, used specifically to escape VM isolation and gain full control of the hypervisor itself. This is the holy grail for a state-level actor.
Can you break that down a bit? If the hypervisor is the ultimate layer, what did they actually do?
Okay, think of a virtualization system like a digital skyscraper. The hypervisor is the foundation and the landlord. It keeps every tenant, every VM, locked in its own apartment.
Okay.
Normally, attackers try to get in through the external network, the front door.
But these guys found a different way.
They did. They got initial access through a compromised Sonic Wall VPN, then deployed a backdoor called VSOCK bucket. And the critical detail is that it communicates using VSOCK.
The virtual socket protocol.
Right. It's an internal trusted protocol. It's like a maintenance tunnel only the landlord is supposed to use. So all their malicious traffic completely bypasses the traditional network security tools that are just watching the front door.
That is the ultimate sleight of hand. You're using a trusted internal system to hide in plain sight.
It's an architectural failure. And what's worse is the timeline. The evidence suggests their exploit toolkit was developed as early as February 2024.
Over a year before it was publicly disclosed.
Exactly. So they were operating on this multi-year timeline.
Yeah.
It just makes you wonder what else is out there right now, quiet.
For sure. And shifting gears slightly, another systemic flaw getting a lot of attention is this ORM leak vulnerability. This isn't just one piece of software. This is about how we build database applications.
Correct. ORM is the object relational mapper. Think of it as the translator between your app's code and the database.
So it converts the request into something the database can understand. Where's the leak?
The leak happens because applications are built to trust the parameters a user provides for filtering. Let's say, show me data where the ID is greater than 10.
Okay.
An attacker learns how to twist that logic. They feed the translator malicious input that forces it to reveal data it shouldn't. They're using the app's own structure against itself.
And we saw this with authentication bypasses and systems using Prisma and exploiting broken parsing in Vague ORM.
Precisely. And this fragility connects directly to the bigger picture with AI agents. We're relying on LLMs to write and execute code, but their security models are proving to be, well, utterly fragile.
Like that pretty significant failure in Claude Code.
Right. Researchers found 8 different ways to bypass its safety mechanisms and run arbitrary system commands. The root cause was a fragile regex-based block list. The developer basically said, we'll just stop the obvious bad commands.
So it would stop something like arm-rf, that kind of thing?
It tried, but it completely failed against subtle bash variable tricks. Attackers could hide their payload by abusing flags on commands that the developer thought were safe, like man or sort or get.
So the big takeaway there is that block lists are just fundamentally flawed.
They're insufficient. The attack surface is infinite. The fix was moving to a strict allow list model, where only specifically approved commands can run. It's a critical lesson for anyone building with AI agents.
Which brings us to our final segment, where we pivot from the virtual world where all this digital risk shows up in the analog one. We really need to talk about crypto and the rise of physical threats.
This is maybe the most visceral example of that shifting trust boundary. We're seeing an alarming surge in violent physical wrench attacks.
Cryptojacking.
Right. Especially in high-wealth areas in France, this has been a growing trend from 2024 into 2026.
And a wrench attack is literally violence, or the threat of it, to force someone to give up their digital assets. That is a terrifying pivot. It means your security plan goes from protecting a password to literally fearing for your family's safety.
Absolutely. And the weakness they're exploiting is self-custody. Because crypto bypasses banks, anyone with the private key or seed phrase can irreversibly move the funds. The transaction is final.
So how are these attackers even finding their victims? It can't be random.
No, it's highly targeted. They're finding victims from public displays of wealth on social media, for sure, but also from data leaks from crypto firms. We saw this with Ledger. And we have to consider compromised access to new government databases like the EU's crypto asset reporting systems. The intelligence they're using is getting better.
So holding your own keys now comes with an explicit physical risk. What are the key mitigations people should be thinking about?
Well, operational security is number one. Don't flash your wealth. But technologically, the shift needs to be toward using things like time-locked transactions that delay transfers, and more importantly, moving to multi-signature wallets.
So you need multiple keys to move the funds?
Right. And those keys should be geographically distributed.
That multi-sig requirement is fascinating. So if an attacker forces you to hand over one key, the funds are still locked. It gives you a window to react.
Precisely. It turns an immediate, irreversible threat into a time-bound problem where the attacker doesn't get instant control.
But to be critical for a second, doesn't that just add a lot of complexity? Or introduce new trusted parties you have to worry about?
It absolutely adds complexity. But that's the trade-off for resilience against physical coercion. If you're self-custodying serious wealth, you're taking on the responsibility of a bank. And banks don't have single points of failure. The complexity is the resilience.
So to kind of wrap up what we've unpacked here, first, the human trust boundary is fundamentally broken by AI. Second, our virtual trust boundaries, like hypervisors, are being bypassed by these long-term sophisticated exploits. And third, our digital wealth is creating clear, immediate physical risk. It's an incredibly challenging landscape.
This raises an important question. Given the speed and severity of all this, what should your immediate action be? The focus has to be on patching the known critical vulnerabilities before they get exploited.
Which means organizations need to be prioritizing the patch for the Trend Micro Apex Central RCE vulnerability. That has a CVSS score of 9.8. And also, you have to note the CISA directive on the GOG's RCE flaw. If it's on the CISA KEVI list, the known exploited vulnerabilities list, it needs to be patched yesterday.
And compliance is just the floor. It's not the ceiling. You have to go beyond.
Absolutely. And just going back to what you said about the VMware 0 days, that exploit toolkit was being used in secret for over a year. If the threats targeting our systems are operating on secret timelines that long, how much of our current defense planning is just at, based on outdated assumptions about the adversary? What does that mean for how often you audit the fundamental security of your most trusted platforms? It's something to think about as you review your whole security posture.
Stay vigilant out there.
Thanks for joining us. We'll catch you next time.
Spoken Tech for your ears.